711 Boylston Street in Revit. Students have asked, how do I start from an AutoCAD file? I've posted lessons about this, and I'm going to pretend that I'm starting from zero, from ground up. So I'm just going to create a new project. Always use the architectural template. New project. Defaults to level 1, and we're going to place a link from the insert menu, a link to the CAD files for the 711 Boylston Street. So let me find them. I think they're in my archive. I'm going to pause this while I find. Okay, so I found the AutoCAD drawing that I started drawing on. And by default, Revit takes the geometry and pins it. That is, fixes it in space, so you got to unpin it in order to move this. So this is a quick little study I did, taking the elevations and just moving them by the. So I'm going to move this stuff to the middle of my elevation markers. Let's just quickly measure from level 1 to level 2, and I think we can ascertain from this drawing 13 4. I think we said 15 feet. There's a better section, but unfortunately we don't have it available to us in this drawing. I'll find it. But I'm going to make, let's see, if I go to my south elevation, Revit by default creates levels 1 and 2 and places level 2 at 10 feet. I'm going to make level 2 at 15 feet. And I'm going to use level 1 as my base constraint, level 2 is my top constraint, so if I change those elevation values, any geometry created with those constraints is going to move with it. Any grid-based system, you should draw the grid line. So I'm going to go in and start doing this. Architecture, grid, architectural elements are data elements, and I'm just tracing over the existing column grid, not being terribly careful about where I place them right now, but I want to make sure that I identify and I can fix them later in space. 1, 2, 3, 4, 5, 6. Usually the horizontal grid elements are numbers, but if this is using Boylston Street as the elevation, it may be that the drawing's rotated at 90 degrees, so that's why we see numbers on this side. It doesn't really matter for what we're doing. One of the things that you can do in Revit, you see the AutoCAD underlay drawing. Columns are in yellow. They're not really reading very well, so I can go into VG, Visibility Graphics, and change the color, assuming they're on the column layer. I'm just going to override the color of the column, so let's change them to blue. So now all my columns turn blue. I'm moving through this very quickly because I'm assuming that you students know this grid line isn't going through anything, so let's move it to something. Columns there. Conceivably, the exterior articulated engaged columns or pilasters or whatever these are could be considered a grid element, but they don't really line up or coincide with the grids. The column grid inside. I'm just changing these to correspond to the letters. We need another grid line here. F. I'm off by 1. So someone decided that the exterior walls participate in this grid system. That's kind of bogus because the grid line is not at the center of anything. So this grid line in AutoCAD, it really goes to the outside, no matter. Okay, so let's save this before we do anything else. File, save as, and this will be available in my handouts folder in my Saturday student workshop. Handouts. I'll make a folder for 7-Eleven. How are we doing on time? 8 minutes, not bad. Handouts. Saturday Student Workshop, and let's create a folder called 7-Eleven Boylston Store Front, because it's a storefront condition that we're modeling in Revit. Boylston in Revit. In Revit 2018 for that. So what's the first thing we're going to do? This is kind of counterintuitive, but the main thing to do when you're modeling a storefront is you want to define as quickly as possible the perimeter, the building perimeter. Even though a lot of that storefront may be articulated, as is indicated in these elevation drawings, right? There's an engaged column, it has a profile, it is rusticated, articulated, otherwise drawn out, but the condition is basically the same. We have regular intervals of what I'm going to call a curtain wall. So there's a sill, it's about 2 or 3 feet high, there's some glazing panels, there's a transom mullion, and then transom glazed panels, and that's the condition that we're modeling. So we have to start with a wall, and we're going to choose a thickness for that wall, and I think it's going to be fair. So I'm measuring at this thick point 2.4. Right? Let's imagine that there's a wall of that thickness around this perimeter, and at least it goes as high as the sill, right? So I'm going to go to Architecture, Wall, and take our generic 8-inch wall, duplicate that type, and call it a generic 2-foot 4-inch wall. Okay? Okay. Let's draw in a clockwise direction, so we will use as location line exterior, finish face exterior. Let's make the top constraint, base constraint is level 1, make the top constraint up to level 2, so we're going to draw up to level 2, which is 15 feet. And I'm going to start drawing here, because I want to proceed clockwise, and finish face exterior. I'm going to pick the outside of that columnar element. Snap to these endpoints. A little bit of faith involved here. So what do we need to align to where we ended up there? Looks like that's going to be the intersection of the AutoCAD. Something's wrong. This wall isn't thick enough. Let's go to here. Let's stop there for a second and see what we did wrong. I think I did not save the thickness of the wall, so I'm going to edit structure here. I don't know why I skipped this. So 2.4 and hit OK. Okay. Because I used a finish face exterior, that alignment is still in place. So we're using what may be an unusually thick wall, but it doesn't really matter for now. Right? Let's ignore this whole system here. And that's what we have so far. So if we go to our 3D view, that's all I got. We need columns as well. I'm jumping around here, but you can follow along. Architecture column, our architectural columns, and I think we need the round ones. They're not loaded, so we have to load them. Load family. Columns. Round column. I think these are about 10 inches. 12 inch might be too thick. That's okay. That grid line is not quite centered, is it? Column. Architectural, not structural. Let's edit this type and make it a 10 inch. 10 inch. And then modify its diameter to be 10 inches. It can always be changed afterwards. So that's more like what we have. And I'm placing these at the intersection of our grid lines. Oops. So that if we refine the location of our grid lines and those change, the columns are going to move with it. We have this rather massive column here, so let's change to, that might be a 24 inch diameter. It's probably less than that. 18, 12, it's too small. Let's edit the type, duplicate and make it 18. We'll align that afterwards. Back to our 3D view. And all our columns are drawn at level 1. The top constraint is level 2. They move with the grid, so when our grid lines change, that will change. Okay, we're 20 minutes into that lesson, so I want to make this into readily digestible lessons. So I'll stop here, and we'll call this Lesson 1. Define building perimeter and column grid and columns.